Yeah, drop, hey, huh.
Yo, what's up guys, this is 𝗪𝗚𝗟𝗟𝗟 and today we're playing Great Old Talisman from UNI CTF 2023, if I remember correctly. This is a pawn challenge I made back then. It only has a few souls, but it's not that difficult, so let's go. We download the files right here and we get this zip file. We unzip it with unzip great old talisman.zip and the password is 𝗪𝗘𝗥𝗘. After that we get flag.txt, which is fake flag for testing, and this binary. Let's see what this binary is. Oh my god. Okay, so it's a 64-bit executable and it's dynamically linked. It's nice, and let's run it. Okay, this great old talisman will protect you from the evil powers of zombies. Do you want to enchant it with powerful spell? Yes, no, yes. Okay, and the spell 𝗪𝗪𝗟𝗟𝗪𝗪. Okay, so there's no format string, we cannot leak something like that. And let's go inside the debugger. Okay, we run it 𝗪𝗪𝗟𝗟𝗪, and what we see, we have partial relo. This is the key point of the challenge. Okay, canary and X, and there is no pi, that's nice. From what we see right now, we can understand that we might not have a buffer overflow due to canary, and as we saw from the simple binary, might not be leak somewhere. So let's go, we go inside binary ninja right here, we search for main, and we see this. So we have a setup function, a banner function, printf, this is blah blah blah, and isoscanf, this is our choice right here, %d. Okay, so choice. First of all, we need to see here that there is no check. I mean, the interface said 1 or 0, but there's no check, so we can do whatever we want. Let's say out of bounds right, probably. And after that, we have spell, and we read inside spell from the keyboard 2 bytes, okay. And inside the talis global variable, global array probably. And as we can see here, the, let's say the index inside talis is what we control, our choice. So if you get the point here, we actually have control over the index inside the talis buffer. So we can tell it, okay, write these bytes there. We have a write what where primitive. And how we're gonna abuse it? We're gonna abuse it by writing out of bounds, somewhere ahead, somewhere before, who knows. And let's see what else we have. After that, okay, we only have exit. So after our read, there's only the exit function. So not much to do. We don't even have return override. Let's check for another functions, something good, something good. Okay, so right here we see a read flag function. I made it too simple right now. So what we actually want to do, we have a write what where primitive, and we have a function that prints the flag, and the only function that comes after our read is exit. So if you take it one by one, we can only override the exit function to be read flag. That's the only way we can get the flag. And why we can do that? We can override the GOT table of exit because there's partial relo. If it was full relo, this wouldn't be possible. But right now we have partial relo, so we can actually do that. And let's see how we're gonna do that. So we right here, bin main, let's say, run, doesn't matter. So let's print talis. We see talis is right here, 4040A0. And let's see what happens while we have before talis 0x20. So we actually see that 0x20 bytes before talis, there is exit at GOT. You could say, okay, how did you find that? That might be guessy. No, it's actually not guessy. I was just searching for talis right here, And if you do this, or oh my god, okay, I cannot write. So if you go here and if you print more, for example 10GX, you can see what actually happens, what comes before and after tallies, and we saw that the exit function we actually want is right there, so this is pretty nice. And how we're gonna overwrite it and with what, let's head to our solver and find out. So this is my template. If you have seen my videos, no, this is the basic stuff. So what we're gonna do here, we're gonna calculate the offset from tallies, the buffer we can write, and the address of exit. So the offset is gonna be, we say that it's before tallies buffer, so it's minus, and we want 𝗙𝗢𝗟𝗟𝗟 tallies, or we could simply take this right here and we subtract from that 𝗙𝗢𝗟𝗟𝗟𝗢, which is this is the address of exit at GOT, and to be precise we divide by 8 so we don't overwrite something we don't want. We want it precisely to be there, and let's send that tar.sendLine, we need string offset. And after that, right now, imagine we have this scenario. Tallies have something like this, actually. IDX, and this is IDX. So whatever we send right here, our offset, should be the index of tallies. So this is what we are doing there. And after that, we want to tell them with what, overwrite it with what. And it's pretty obvious. r.sendLine. Right here, we want only 2 bytes because we can only read 2 bytes of the read flag function. I'm too lazy to do that, so I'm just gonna do 332 a.sim read flag. This will just pass the 2 bytes and the rest will go to waste. We don't care. Don't care. Let's go Python solver. Okay. And we say that we actually managed to get the flag locally. And I'm pretty sure the same will happen remotely. So we go here, false Python solver, and copy paste that. And we say that we actually managed to get the same flag, not the same flag, to get the flag remotely. So that was the challenge, guys. It was pretty simple. I mean, you have an out of bounds primitive with write what where, and we saw that there is partial relo in the challenge. That means we can override GOT addresses like the exit, which was the only function that comes after our read. And that was it. I mean, if you see, it's actually 2 lines. It wasn't that difficult. So that was it, guys. Thank you for watching. If you have any questions, leave them in the comment. Have fun and see you in the next video. Bye. Oh, don't forget to subscribe to the channel.